Hello all, and welcome to the Expert Metasploit penetration testing video series. In this video, we'll be covering various aspects of penetration testing using the most popular open source framework, Metasploit. The entire video series has been divided into 8 different sections. Within them, we'll be covering all the important aspects of Metasploit and how we can use this framework in order to enhance our penetration testing capabilities. The requirements for this entire video series are pretty simple. For the complete setup, we can have the Backtrack 5 operating system. This comes with a pre-installed copy of Metasploit. Apart from that, if you have a Windows operating system, you can download the Metasploit framework from its official website. We will also be requiring Armitage and Nmap as our supporting tools while we are working over this video series. Apart from this, we will also be requiring a database setup. Metasploit supports by default PostgreSQL database, which can be either installed separately or installed alongside the Metasploit framework download. Finally, it's highly recommended that you use the Backtrack 5 Linux-based operating system. The reason for this is that it already has the entire framework pre-installed, along with other required dependencies, as well as third-party tools like Armitage and Nmap. So this was a quick demonstration about the requirements of this entire video series. Following on from this, we'll now quickly jump into our first section, where we'll be covering different aspects of scanning and information gathering. We'll start by launching our Backtrack session. Now, in order to launch an Nmap scan, or to view the different Nmap options, we can simply type Nmap and press Enter. Here you will see that it will reflect the different parameter values that we can pass during a scan. Here you can find the entire list. We'll just quickly go through the entire list. For example, we have the SS parameter, which is basically a SYN connect scan. This is then followed by the SN parameter. We then have the P parameter, where we can specify the port range. Finally, we have the SV parameter, which determines the port service, version, and so on. Based on our requirements, we can use these parameters in order to get more results out of our scanning process. To launch a very basic scan onto our target machine, we can use Nmap scanner, followed by its IP address. Nmap then begins to scan the IP address, which in this case is 192.168.56.102. The output results show that there are 3 open ports, port number 135, 139, and 445. Now, in order to increase the complexity of this scan, we can scan the entire subnet instead of a single host. For example, given the scan parameter that is Nmap 192.168.56.1-24, Nmap will then look for every IP address that lies within the range of 56.1 until 56.255. It will scan the entire subnet for live hosts. Let's pass this command and analyze the output. Now, once the scanning process is complete, you'll see that multiple live hosts have been returned. In this case, it is reflected the live host as 56.1, as well as showing that this port has multiple open ports on it. It has also identified 56.100 as a live host, 56.101, and 56.102 as other live hosts. So from this, you can see that a single command has reflected the scan of the entire subnet in order to figure out the live hosts. So this was a quick demonstration of how we can use Nmap in order to identify and gain information about different systems which are live in our target subnet. In our previous video, we started with the basics of Nmap scanning, where we used Nmap commands to scan a single target. Now, if you look at the help file, you'll notice that there are multiple parameters that we can pass to an Nmap scan in order to get more accurate results. If you look at some of the important scanner parameters, such as SV, these are looking for open ports to determine service as well as version information. We also have ST and we have O, which is used for operating system detection. We can also add a time-based scan to limit a minimum amount of time that is required to scan a particular port number. So if you look at the different scan parameters available to us, we can pass the ST parameter, which can look for a TCP scan. We can also have an SYN scan, which is the SS parameter. This is considered as a stealthiest scan to override firewall protection. We can also have an ACK scan with the SA parameter. It scans by sending different ACK packets to the target system. All different scans are similar. The only difference lies in the type of package that is sent to the target in order to determine the open ports. So let us do a simple TCP scan on our target, 192.160.56.1, and figure out what result it returns. You can see that it has returned different ports open along with the services running on the particular port. Similarly, we can club multiple parameters into a single scan type. I can club the TCP scan with a version detection scan, if I also have to figure out the different versions of services that are running on it. Let us see what result this scan returns. In a few minutes, you'll notice a more descriptive result, returned by Nmap this time. As you can see, it has to detect different versions of operating systems that are running on our target system. We can see, for example, that 912 is running a VMware authentication daemon. Similarly, we have the RPC service running multiple ports. So, this is how we are actually identifying the different versions of services for the open ports. Furthermore, we can perform another interesting scan to detect the operating system that is running on our targets. To do this, we'll be using the O parameter. Let us see how the Nmap successfully determines the operating system of our target system or not. Nmap has returned a slightly confusing result, running Microsoft Windows 7, Vista, or 2008. This is because the operating system detection is completely based on the different ports which Nmap detects. If, by default, it identifies the port number 445 is opened, and a NetBIOS service is running on it, it will certainly be a Windows operating system. Now, based on the versions of NetBIOS and the other parameters, Nmap tries to figure out which version of Windows it actually uses. So in our case, operating system detection is a little mixed up, even though Nmap has tried to figure out that it is Microsoft Windows 7 Professional. In many cases, this result can be false. It's still a very important scan type to try and figure out the operating system running on our target machine. So this was an advanced discussion about Nmap. You can try out all the different parameters that are there by using the help command. Clubbing the multiple scan types using different parameters can make our scan more understandable, more enhanced, and can also return better results. In this video, we will learn about Metasploit and how to use its database to store our penetration testing results. To start with, we'll be using Nmap to store the results of our Nmap scans. We'll start by looking at the available drivers in our Metasploit session. In order to do this, we simply type db_driver to see the available drivers. Here we can see that we have PostgreSQL as well as MySQL. In the newest version of Metasploit, MySQL support has been dropped. We can also check the current status of our connected drivers by typing db_status. This will tell us that PostgreSQL has been connected to Metasploit. In case any of the drivers are missing from our system, we can simply do apt-get install PostgreSQL. This will install PostgreSQL on our system. Furthermore, you can change your directory to opd framework3 config and view the database YML file. Here you will see the default configuration of your driver Postgre is database MSF3. It has already been created with the username MSF3, password, and a host along with other details. Now in order to start working, we can see that we already have a connected database. In case your database is not connected, you can simply use the db_connect command, then follow the command pattern to log in. You can get the username and other details from the database YML file. Let us start with a simple Nmap scan. We'll be using db_nmap. This command is particularly used to store our Nmap results into the Metasploit database. So let us scan the entire subnet, which we saw in the previous video. We'll then see the results returned by Nmap. We can see that Nmap has returned multiple live hosts, and all of these values are automatically populated into our database. Now to view the content of our database, we can use multiple commands. For example, to view the available host, we can use the db_hosts command. You can see that 3 hosts have been added to our database. Similarly, you can further use db_hosts cmac for better results. From this, you can see we only have a particular table listed which corresponds to the MAC values. So this was a quick demonstration of how we can use database integrated with Metasploit. There are multiple database commands that are available to us. To view all the commands, you can simply type help in the MSF console. You will find multiple database backend commands such as adding credentials, adding drivers, and importing an existing file. Importing can be used when we already have an XML file or any database file that contains previously used penetration testing results. These can then be directly imported to start our work again. We can also have support for multiple tools such as Nessus. And finally, we can generate multiple file types as well. In this video, we'll be learning about using Metasploit auxiliary modules for scanning. Auxiliary modules are special purpose modules that are designed to perform a specific task. There are multiple auxiliary modules available to us. To view the different modules, you can simply change your directory to pentest, exploits, framework 3, modules, auxiliary. Here you can see the different types of auxiliary modules available to us. We have scanner, we have crawler, buzzers, and so on. Now we are particularly interested in scanner modules, so let's move to this directory. You can see that there are different specific types of auxiliary modules available: Postgres, SQL, PortScan, SMB, SMTP, and so on. Now let us move to our MSF console and see how we can use these auxiliary modules to perform our scans. In order to use any auxiliary module, we follow 3 simple steps. The first step is to activate the auxiliary module. The second one is to pass on the different parameter values, and the third is to run the module. So let's do a quick search for PortScan modules. We can see that several PortScan modules have been returned by Nmap. Let us do a quick TCP scan using any auxiliary scanner module. The first step will be activate the module. To do so, we will pass on the use command. So use auxiliary, scanner, PortScan, TCP. The second step will be to pass on the respective parameter values. View the required parameter values by typing the show options command here. We can see that we require multiple values like concurrency, filter, interface, ports, rhosts, and so on. Those marked as yes are mandatory values. They should contain some value. There are also some default values passed as well. Let us pass the rhost value, which is the target address that needs to be scanned. Now let's change the value of ports to a smaller value. Let us do a show options again. The values are set now. The third and the final step will be to run the auxiliary module. So let's see what result it returns. In a few moments, you'll see that TCP scan has resulted some open ports on our target system. This was a simple demonstration of how we can use scanner modules in Metasploit. There are multiple module options available. The question here is how auxiliary modules are more useful than Nmap. Suppose that we have to look for a particular type of service, such as PostgreSQL, or we have to look for the MySQL server. Then we cannot directly run Nmap and look for a MySQL server. In those cases, auxiliary modules are particularly beneficial when we're targeting a particular service on our target system. In this video, we'll be learning about scanning through Nessus. Nessus is a widely used vulnerability scanning tool. It goes a step ahead of Nmap. In Nmap, we were only able to figure out the services that are running on open ports. Nessus takes scanning and information gathering to the next level by also identifying any possible vulnerability that can exist on the service that is running on our target system. In order to start Nessus on Backtrack, you can go to Applications, Backtrack, then go to Vulnerability Assessment, Network Assessment, Vulnerability Scanners, and then finally Nessus Start. For the first time, you have to start Nessus. Once you click on it, you'll get an error that the plugin is missing, and you have to register at nessus.org. This is the first time that we are starting Nessus, and that's why we're encountering this error. Now what you have to do is visit the website and register for a code. Here is the Nessus website, where you can select the use of Nessus, for example, selecting it for use at home. You can accept the agreement and further fill the form. From this, you'll get an activation code on your email. Once you get this activation code, the next step will be to register your Nessus on this system. What you can do is fetch the directory opt/nessus/bin fetch and register along with your registration code. Once you pass on this command, your activation code will be accepted and Nessus will now be ready to run. Once you are done with this, again move to Applications, Backtrack, Vulnerability Assessment, Network Assessment, Vulnerability Scanners, and finally click on Nessus Start. We will then see a message stating that Nessus is running. Now you can move to your browser. After moving the browser, you can now visit localhost at port number 8834. You will see that Nessus is initializing. I've already initialized it since it takes a bit of time to activate. This is how we set up Nessus on a fresh system. Alternatively, we can also work on Nessus even through the backtrack command line in MSF console. For example, here we have an active MSF session. Now to start Nessus, you first have to check whether your database is connected or not. You can use check db_status. From this, you'll be able to see that Postgres has been connected. Now you can simply pass load Nessus. Nessus should now be initializing and will have successfully loaded the Nessus plugin. Here we can type msf nessus help for a command list. You will then be presented with a list of commands that we can pass to Nessus. As the plugin is loaded, simply typing the help command will also list the Nessus commands in backtrack. You can see that in order to connect to the server, you can use the Nessus connect command. Furthermore, you can start a simple scan by using the Nessus discover command. Exploits can be discovered using the Nessus report exploit commands, and we can also have the retail report about the host using Nessus report host detail. We can have a new scan, we can have it paused, and we can resume. These are the different options and actions that we can perform while working with Nessus. We're now beginning the second section of our video series. In this section, we will be discussing Metasploit payloads and encoders. Metasploit has several payloads or shellcodes in its repository. To start with a basic attack, we are not going into the depth of vulnerabilities. This will be covered in the next section. In this section, we are covering a general scenario where we can create malicious executables or malicious payloads using the available shellcodes in Metasploit's repository. Metasploit comes with a tool called MSF Payload. This is a command line instance of Metasploit that is used to generate various file types of shellcode that are available in the repository. The various file types can either be a C program, or an executable, or a Ruby program, and so on. We can convert any Metasploit shellcode into one of those file formats that use MSF Payload. Later on, we can transfer this generated file to our target system and execute it somehow in order to compromise it. This is an overview of how an attack is framed using MSF Payload, or by generating executables or different file formats using MSF Payload. To start with MSF Payload, we can pass the command with the help parameter into our console. This will list the different file formats for us. As you can see, we can have Perl, Ruby, RAW, exe, and so on. In order to view the available list of payloads, we can simply give the L parameter. This will list all the available payloads in the Metasploit repository. All of these payloads are actually programs that can help us in opening a back connection on our target machine. Now let us see how we can use MSF Payload with our Windows Shell reverse TCP payload. Here you can see that the O parameter is actually used to see details about the payload that we have selected. Now this payload will be setting up a reverse TCP stager and other details like version and so on. Now here are the parameter details that we have to pass before we can create any working file for this payload. lhost and lport are already set. So let's pass the value of lhost to MSF Payload for the reversed TCP payload. Also, let's change the value of lport. If we just pass the O parameter, we can see whether we've passed the value or not. Alright, so the values are now reflecting. If you remember, these are different file formats that can be generated. In order to generate an exe file format, we use the X parameter, that's capital X, along with a path. This will create this 123.exe file name in our root directory. So, our payload or our executable is now created with the file name 123.exe and is saved in our root folder. Similarly, If we have to generate a C program, or we want to view the actual shellcode to add in our own script, we can simply pass the C parameter and press enter. Now let's go back to our backtrack session or our Linux session to see whether the files have been created or not. In the root folder you will find the exe file as well as the C program. When you open it with the editor, you will find that the following shellcode has been generated. Now this program can be called very easily in our own C program, such as if suppose we are working on our own C module for penetration testing, we can easily use the generated program. So, this was a short demonstration of how we can use MSF payload in Metasploit. Starting from our previous discussion, where we learned about MSF payload, in this video we'll be learning about MSF encode. MSF encode is a tool that is used to obfuscate the shellcode that is generated by MSF payload. The reason why we are obfuscating the code is that the standalone executables, or the standalone files generated by MSF payload, can be detected by antivirus programs as malicious. Therefore, MSF encode can be used to obfuscate the source code in such a way that they are undetected by antivirus programs. To view the available list of encoders, we can simply pass on the L parameter along with MSF encode. This will list all the available encoders to us. These encoders are generally the particular algorithm, which is applied onto the MSF payload files in order to obfuscate their source code. To view the operations of MSF encode, we can simply type MSF encode H. This will list the different parameters that are available. For example, we have the E parameter that helps us in choosing a particular encoder from the list mentioned earlier. We have the O parameter for the output file, and we have the T parameter for the different file formats that we can generate. So let us start with the same payload that we used in our previous discussion, that is the Windows Shell reverse TCP. One thing we have to remember here is that the MSF payload and MSF encode command work in conjunction. That is, we can pipeline both the commands together in order to generate a single executable or file format. So our MSF payload command is MSF payload Windows shell reverse TCP lhost equals 192.168.56.101. Let us generate a raw file and pipeline the MSF encode command along with this code. We can choose the encoder by using the E operator. Let us pick up the generate encoder. We can also provide a number of iterations using the C operator. Furthermore, we can generate a particular file format using the T operator. Let us generate an executable and finally a file name which we want to create. Once this command is executed, we can see that a file size of 290 bytes having 2 iterations has been generated. So this is how an encoded form of MSF payload is generated. Let us go back to our backtrack session and see whether our encoded.exe file has been created successfully or not. We'll have to browse to the root folder. Here we have our encoded.exe. This is the same encoded version of the file that we generated using MSF payload. That is 123.exe in our previous video. So this was a quick demonstration of using MSF encode in conjunction with MSF payload. In our previous discussion, we learnt about encoding our payloads using MSF encode. This encoding, or obfuscating of payloads, enables us to bypass the antivirus protections present on your target machine. These encoded payloads can be executed on your target machine in order to open a backdoor entry for further penetration testing. Moving ahead, in this video we will further investigate MSF encode and MSF payload to generate more complex and encoded forms of payloads. We will be using one of the most popular encoding styles present in Metasploit, that is Shikata Ga-Nai. As you can see, it's treated as an excellent polymorphic XOR encoder. Now let us start with a basic implementation and let's choose a different payload. We now need to set the L host. Alright, our L host is now set. Let us pipeline the MSF encode command. Now let's choose a number of iterations as 2, generate an exe and name it newencoded.exe. Alright, so 2 iterations have been performed and finally our file has been generated. It is of the size 54. What we can do here is that we can further increase the number of iterations to increase the complexity of our shellcode. We can further increase the iterations 10 times and rename our file as encoded10.exe. Let us see what will be the new file size. Alright, so now a file size of 270 kilobytes has been generated. But the file is further more complex compared to what we've generated so far. Let's further increase the complexity to 20 iterations for the same payload, and rename our file as newencoded20.exe. The new file created is a size of 540 kilobytes. The complexity is increasing, the file size is also increasing. We have to make sure that we are choosing the correct combination of encoders along with the payload so that neither is the file size too large, nor does the number of iterations go beyond a comparable limit. Now let's go back to our backtrack root folder and see whether our files have been created or not. Here we have the 20, and here we have the 10. So these are the files that have been generated finally. This was a quick demonstration of how we can keep increasing the complexity of payloads using the different available encoders. There is a huge list of encoders, and we can also combine the scripts of different encoders and generate a single encoder of our own, and further implement it to generate a more complex and undetectable payload. In this video, we will take our first steps towards using different exploit modules that are available in Metasploit. To begin with, we'll use a very simple exploit module that is called a reverse handler. Later, we'll move up to more complex modules and see how we can exploit different machines using these exploit modules and set up a back connection. To start working with exploit modules, we generally use two main commands. The first command that we'll be incorporating is the use command, that is use exploit multi handler. The use command is basically used to activate any exploit module that we want to use. Once the command is successful, we'll see that the Metasploit prompt changes to the particular module that we have selected. The second important command that we use here is show options. This command basically lists the parameters that we need to pass to the particular exploit module. Since this is a very basic multi-handler module, we do not have many options in it. The reason why we have started with this exploit module is that we can pass any payload with this module and wait for connection through any type of payload that we have set up in our previous videos. Now let's take another example of setting up an exploit module. Using the back command, we can come back to our MSF prompt. Let us choose another exploit module. Pressing tab will automatically complete the directory writing. So you can see that our prompt has changed to the particular exploit module that we want to use. Now passing show options will reflect different parameters that are required for the module. Here, our host is a target address that we want to compromise. So to set up our host, we'll be passing the set command. This is how we generally use any module in a Metasploit repository. This was the first step of getting started with modules. In the next video, we'll see how we can actually compromise the remote host that we've set up. In this video, we'll be seeking our first hands-on experience towards penetration testing using Metasploit. In the video, what we will actually be doing is setting up a reverse handler as well as a payload. After that, we'll be generating an executable of the same payload, transfer it somehow to our target machine, and run on it. Later on, we'll notice that our reverse handler will set up a back connection, or we'll start listening for a back connection from our target machine. Let us practically implement it on a standard handler. So we've now set up a multi-handler. Let us set up a payload as well. MSF exploit handler set payload Windows shell reverse TCP. Now let's view the options. MSF exploit handler show options. We can also set the local host as the IP address of the attacking machine. Now if you remember, in the third video of this section we learnt about generating executables using payload. Using the same technique, I generated a payload for reverse TCP and somehow passed it onto our target machine, where the executable is saved. Now let's come back to our attacking machine and run the exploit module. So here you'll see that the reversed handler has started, and is now listening for a connection from the target machine. Once this payload, or this executable, is run on our target machine, we'll notice that a back connection has been established between the attacking and the target machine, and we've received a command prompt successfully. In order to verify that it's the same command prompt, just check the IP. Let's check the IP of our target machine and compare them. Okay, that's also 102. Alright, so we have received the shell prompt of our target machine. Now, from here we can easily browse to different directories or different file locations of our target machine using the cd command. From this you can see how easily we have penetrated our target machine using the techniques which we've discussed so far. In the later videos, we'll do much more complex techniques where we'll be actually exploiting the machine remotely. Let us begin with the third section of our video series. In this section, we'll be dealing with core exploitation processes using Metasploit. In the last video of our second series, we saw how we can get a shell on our attacking machine by executing a payload on our target machine. However, this attack is limited to executing that particular exe file on our target machine. In this video series, we'll learn about core exploitation processes, wherein we'll be compromising our target remotely by using known exploits present in the Metasploit repository. We'll start with a very basic Windows XP Service Pack 2 machine, and later on we'll see how we can get a remote shell, or how we can compromise other versions of Windows like Windows 7, and so on. So let's start with a very basic Windows Service Pack 2 machine. We can see that one user, Dark Lord, is already added to this machine, and the guest user is signed off. Now we will launch an attack where we'll be adding another user remotely onto this PC. One thing I would like to make clear here is that this is a machine set up in order to demonstrate the attack. Similarly, we can attack any remote PC available anywhere on the internet if we are aware of the IP address and the operating system version. So let us begin with our Metasploit console. We'll be exploiting the Windows Net API vulnerability, so let us do a quick search of the Net API. Okay, so the Net API has resulted in 4 exploit modules. Let us select the latest one, that is 08067 Net API vulnerability. We'll be using exploit Windows SMB MS08_067_ NE API and do show options. We need the IP address of the remote host, so let us quickly check what the IP address of this machine is with ipconfig. It is 192.168.56.102. So let us add it here. Let's now set up a payload, and then show options. Alright, so our host is set. Our port is by default set as 445 to exploit the API vulnerability. Plus, payload has settings adding a user Metasploit and password Metasploit. Let us change it to some other value. Set user as packed and set pass as 123. Now let us launch the exploit by typing exploit and pressing enter. Now you can see what it shows. It's tempting to trigger the vulnerability. An exploit was completed but no session was created. This is because we are actually adding a user remotely instead of getting a session on it. Let us now go back to our XP machine and see if we have successfully exploited the machine or not. We see that we just have one user. Let us log off and check. Okay, so we have a packed user added here. Clicking on it and adding 123 as our password will log us into the XP machine. So this was a simple attack demonstrating how we can remotely compromise any XP machine using the Net API vulnerability. Just like I provided the local IP, because this machine is present on the same network as the attacking machine, you can provide any remote IP and listen on that particular Ethernet to exploit machines that are available on the internet remotely. In the previous video, we saw how we can compromise a Windows XP machine remotely using the Net API vulnerability. Later on, we added a new user to the machine remotely. In this video, we will take the attack a step ahead and we'll try to get a back connection or a shell prompt on our target machine. We'll start by using the same vulnerability. We'll use MSF use exploit Windows SMB MS08_068_net API, as well as then MSF exploit show options. We need to provide the IP address of the remote machine that we want to compromise. We'll do this using MSF exploit set rhost 192.168.56.102. Now this time let us choose a different payload. We have MSF exploit set payload Windows shell bind TCP, and then show options again. So the rhost is already set. Now let us exploit the machine. This time we can see messages such as attempting to trigger vulnerability, sending stage, and command session opened. So this means we have successfully opened a shell prompt that belongs to our target machine. Now from here on we can easily browse a target machine and play with different files by downloading them or copying them to our machine. We can also do this by looking at different files or by looking at different disk partitions available on our target machine, and so on. all the commands that are applicable to the DOS prompt will be applicable here as well. We can do a quick dir to view all the files. You can do a cd to change the directories and so on. In this video, we'll learn about the directory structure of Metasploit. In the previous video, we saw how we can pen test a Windows XP SP2 machine using the exploits tools as well as the payload modules available to us in Metasploit. Furthermore, in the previous couple of videos, we have extensively used different types of modules such as the encoders, auxiliary modules, or exploit modules. In this video, we'll get a closer look at the directory structure of Metasploit. This will help us in locating these files inside the repository so we can manipulate or modify them according to our needs. To start, let us quickly change our directory to pentest exploits framework 3. This is the main directory where all the important core commands as well as the modules of Metasploit are located. You can find MSF console, MSF encode, MSF payload, and so on. We have seen all these commands so far in our video series. You can also find a modules directory where the modules of Metasploit are located. Furthermore, here you can find the auxiliary modules, encoder modules, exploit modules, payloads, and so on. So this directory structure helps us in understanding the actual modular structure that Metasploit implements. The basic benefit of implementing this modular structure is that at any stage we can add our own exploit scripts within this directory in order to make Metasploit understand that it belongs to an exploit structure. Let us change our directory to exploit modules and see what is available to us. Here we can find the different applications as well as the operating system based modules. The exploit module is further categorized based on the type of operating system or the type of security suite it is compromising. Here you can see that we have dial-up, free-based, OS X-based, Solaris or window-based modules. Let us change our directory to Windows. This directory is further classified into subdirectories, where modules are based on their protocols or based on their application structure is located. You can find FTP, IMAP, browser, firewall-based, file format-based, and different modules. This now gives us a clear idea of how modules or how different exploits are categorized inside the Metasploit framework. Now, let us also look at the Linux structure. You can see that it's pretty much similar to that which we have seen in Windows, even though the module strength is less compared to that of Windows. Let's now move to our Linux machine and locate these modules. Here you can see that we are inside the exploits window. Now let's locate the SMB directory. Here we can find ms08067 netapi.rb or the Ruby script. If you remember, this is the same module that we've used in our previous videos. Opening this script inside any text editor, we can actually see what is happening behind the scene. If you have a fair idea of Ruby programming, then you can easily figure out which exploitation process is going on inside this module. At any stage, you can easily modify any part of the code and use it as your own script within the Metasploit module. Furthermore, this modular structure or Metasploit gives us the power of extending the framework by reusing the code. This is why the open source modular nature of frameworks makes it a very powerful tool. Now that we have understood the directory structure of Metasploit, we will move ahead and work on a Linux machine for penetration testing. The point to note here is that since we are targeting a Linux machine, our exploit and payload will be specific to the Linux operating system. If you remember, in our previous videos, we saw that the exploits as well as the payloads are categorized based on the variation in operating systems. Therefore, if we are targeting a Linux-based operating system, we will have to select the respective exploit as well as the payload. Here, we will pick up an ideal scenario where we will first be targeting our Linux machine by doing a quick port scan to figure out the available services. Then, we will search in Metasploit to figure out if we have any available exploits based on the services that are running on our target. We will start by launching an Nmap scan along with version detection and see what result it returns. As you can see, Metasploit has returned some open ports. We can see that we have an SSH service, RC bind service, and Samba service running on a Linux machine. Samba can be a point of interest for us. So now we can search for Samba inside Metasploit to see if we have any available exploit modules. As you can see, Metasploit has returned a few results. We have some Linux-based Samba exploit modules available to us. Let us try with the LSA transnames heap exploit module, which has been ranked as good. It's basically a heap overflow module inside the transnames function defined in the Samba library. We'll be following the usual process, and then we will show options. Here you can see that the required R port is 445. If you remember, in our Nmap scan, we also figured that the 445 port was alive. Hence, this exploit can be applicable on our target machine. We need to set the R host. After setting the R host, our next target will be set up the payload. We have to make sure that we choose a payload that is relevant to the Linux operating system. Let us quickly go through our file system to figure out what Linux payloads are available. So here we are in our modules folder. Browse the payloads, from there to singles, and thus you'll have the Linux folder. We can choose xb6 and can find different payloads here. Now let us choose shell bind tcp.rb for our current example. Now we can do a quick show options command to figure out what values are required for this payload. As you can see, all our required values for the exploit modules are complete. So this was a quick demonstration of how we can choose a particular exploit based on the services available on our target machine, and then selecting the respective payloads based on the kind of operating system that we are trying to penetrate. Let us begin with the fourth section of our video series. In this fifth section, we'll be diving deep into the penetration testing process using Metasploit. Here, we'll be using some very popular client-side vulnerabilities to exploit our target. So let's begin with an Internet Explorer-based vulnerability, Microsoft MSXML, uninitialized memory corruption. This is a Metasploit webpage which gives some details about this vulnerability. We can see that it affects a good number of targets and almost all versions of Internet Explorer prior to version 9. So, exploit can be very helpful for us in attacking our target. In this video, we'll be targeting a Windows 7 machine running Internet Explorer 8. So let's begin with our attack by launching it from the MSF console. This is our exploit module. Once it has been set, our prompt will change according to the exploit module. Let us do a show options. We require SRV host, which is a local host to listen on. We can now set up a payload as well. We can again do show options. We require lhost, which is a local address to listen on. Once we are through with this, we can type exploit and press enter. So here you will see that a local file has been created with the following URL. Now, all we have to do is transfer this URL to our target machine and somehow convince the person to execute it via the Internet Explorer browser. After some time, you'll notice that Internet Explorer has crashed and has resulted in an error. On our Metasploit prompt, we'll notice that the exploit is successfully complete. It has also sent our payload onto the target PC, and we have a Meterpreter session open, which is now running as a background job. We'll go into further details of migrate and so on once we cover Meterpreter sessions. Let us now see whether we have the session live or not. Typing sessions with the L parameter will list us the available machines with whom we have a live session right now. So, here you can see we have a Meterpreter session with a PC with the IP address of 192.168.56.103, which is our Windows 7 machine. We can activate this session by typing sessions with the I parameter along with the session ID, which is 1 in our case. So, here our Meterpreter session is now launched. Let us now move ahead with our client-side vulnerabilities discussion. In this video, we'll be covering another client-side exploit that exists in Adobe Acrobat Reader. Adobe Acrobat is a tool for viewing media files. We'll be covering the Adobe Acrobat libtiff integer overflow vulnerability, which exploits Adobe Acrobat versions ranging from 8 to 9.3. We can see this vulnerability is affecting a large number of versions, hence it can be a good option in order to penetrate our target. So let's first move to our console. We'll first be setting up the exploit module. So, the exploit module of the exploit is a file format vulnerability, hence we have changed our directory to Windows/file format, selecting the libtiff vulnerability. Let us now do a show options here. Here we can see that a file name will be created locally with the name msf.pdf. Let us change it to a less suspicious name. Let's now set up the payload. Again, we'll be using the Meterpreter payload. The Meterpreter payload requires a local host to listen on. Typing exploit will figure out that a local file will be generated in our root directory with the name report.pdf. The next step was to transfer this report.pdf file to our target machine using some social engineering technique and convince a program to open the PDF file using the Acrobat version. Here I'm assuming that our target is using one of the affected software versions of Adobe Reader. Let's consider that we have successfully transferred the PDF file onto the target machine. Now, once the target user executes this PDF file, we'll notice some activity on our MSF console. In our case, what can arise here is that we may exploit window in order to do some other task. In that case, we can also set up a reverse handler. That is, we can use another session to set up a reverse handler, which we've seen in the previous video. So even if we're carrying forward with our other jobs, we'll still be listening for a back connection from our target machine. So irrespective of the time the file is executed on the target machine, we'll be getting a back connection onto our attacking machine. Now by executing the malicious PDF onto our target machine, we can get a back connection on our reverse handler that we have set up. Here we'll notice that successful exploitation will result in a Meterpreter session. On the target machine we can either have an application crash, or the Adobe Reader may not respond, which can lead to denial of service. This depends completely on the stability of the operating system or the application. This was, again, a very simple demonstration of using client-side exploitation for penetration testing using Metasploit. Let us move to the third part of our client-side exploitation technique. In this video, we'll be discussing a Java-based vulnerability. Java is generally a platform-independent language, so irrespective of the kind of operating system running at our target, we can successfully compromise it if we're targeting on a Java vulnerability. In this video, we're going to cover the Java applet field bytecode verifier REC vulnerability, which has the CVE as 2012-1723. As you can see, is also rated as an excellent exploit module inside Metasploit. Let's now quickly jump to our console. Since this is a multi-platform vulnerability, we are using a multi-directory here instead of Windows, which we've seen in our previous videos. Let's now do show options. So the required parameters are SRV host and SRV port. Let's set up the SRV host. In this case, we'll be setting up a Java-based payload because it's multi-platform and Windows-based payloads will not be applicable here. This is very much similar to what we've seen using our Windows-based payload. As you can see, we require the same value, which here is lhost. Once we're through with this, we can type exploit to launch our module. Here we can see that a local file has been generated onto the server with the following URL. Let's pick up this URL and transfer it somewhere to our target machine. Let's launch the browser with this URL. If you notice in Metasploit console, you will see that it starts reflecting that machine with the IP address 192.168.56.103 is trying to open this particular URL. The jar has been sent and the successful exploitation has resulted in a Meterpreter session. By listing the sessions here, we can find the ID and the type of session that we have, along with the IP address of our target machine. Passing the I parameter along with the session ID will give us the Meterpreter prompt. Here you can see that we've successfully compromised an unpatched Windows 7 machine running Internet Explorer using the Java vulnerability. let us move to another important client-side based exploitation technique. In this video, we'll be covering Microsoft Office-based vulnerability. As we all know, Microsoft Office is a very popular tool across the Windows platform for creating and viewing Office documents such as Word files, presentations, and so on. Therefore, leveraging a vulnerability in this platform can increase our chances of penetrating our target successfully. So, here we'll be targeting the Microsoft Word RTF stack buffer overflow vulnerability that exists in parsing of the RTF documents. As you can see, this vulnerability affects all the latest versions of Microsoft Office, including 2010, 2007, 2003, and so on. If the Office pack is not patched up with the new definitions, we have a chance of compromising our target if the target is using a vulnerable version of Microsoft Office. So let's now turn to our Metasploit console and see how we can launch this attack. Since it's a file format-based vulnerability, we'll again be using MSF, use, exploit, Windows, file format, MS10, 087, RTF, pfragments, BOF. And now we can also do show options. As you can see, similar to our Adobe vulnerability, an RTF file, that is filename msf.rtf, will be created, which can easily be changed to some other name. Now let's set the payload. We'll now be requiring the L host again. Now we're done. So, all we have to do is run the exploit command and Metasploit will generate a vulnerable RTF file for us. This is the file that we're going to use as part of our penetration testing. It's very similar to the Adobe vulnerability, which we saw in the second video of this series. So the social engineering will be involved here to transfer this malicious RTF file to our target machine. Once the file is executed or opened through a vulnerable version of Microsoft Office, we can get a shell connectivity with our target machine. Alternatively, we can also set up a reverse handler. As we've discussed previously, we can carry out other regular penetration testing processes using the reverse handler. The reverse handler will always sit and listen for a connection at a particular port. Then the particular RTF file will be executed on our target machine. This was a very quick demonstration of how we can use a very popular Microsoft Office to build up a scenario for penetration testing our target machine. In this video, we'll be covering a very popular aspect of Metasploit, which is called browser autoporn. The basic idea behind browser autoporn is to create a single repository of multi-browser exploits that can be accessed via a single link. Once that link is visited on our target machine, it can further call out all these exploits one by one until or unless we hit a successful exploitation process. Browser autoporn has gained a lot of popularity these days in the penetration testing scenario because it reduces the work of trying a single process at a time. Browser autoporn gives us the power of attempting multiple exploit modules in a single go. So, let us practically implement this module and see how we can generate a penetration testing scenario using browser autoporn. Since it is an auxiliary module, we can launch it from our MSF console by using auxiliary server browser autoporn. So, we require a local host where we can have a reverse connection. Also require an SRV host, which will need a local address on which the connection will listen. Once we are through with this, we can type exploit and press enter. So, here we can see that multiple exploits are now being set up onto the server with a URL link as well. Metasploit will keep on generating several exploit modules along with payloads in order to get a connection back onto our attacking machine. Here we can see that Metasploit has created a complete server of 41 exploit modules, which can be accessed via the final URL. The URL is going to call all these previously mentioned exploits one by one until or unless we see a successful exploitation process. So, now let's execute this URL on our target, which is a Windows 7 unpatched machine running Internet Explorer version 8. Here, on our Metasploit console, we can see that a successful exploitation process has been hit using the MSF11 CSS import vulnerability. Now, once the exploitation process was successful, the Meterpreter payload was immediately injected into the target. Successfully received a back connection. Listing the available sessions, we can find our target listed here. So, here you can see how easily we've exploited without even considering a single vulnerability at a time. This is the real power of browser autoporn because we are targeting multiple exploits in a single go. However, this browser auto-born technique also comes with a drawback. That is, in many cases the browser crashes due to the random exploits that are sent onto it. Therefore, stability decreases greatly while we're using this exploitation technique. Let us begin with the fifth section of our video series. In the past sections, we have mostly focused on pre-exploitation processes, where we try different exploits, modules and payloads in order to penetrate our target machine. We also targeted different types of operating systems, such as a Windows XP machine or a Windows 7 machine, a Linux machine, and so on. Now the question which arises here is what we can do after exploiting or penetrating the machine. If you remember, we left many videos at this Meterpreter session where we are right now. From this video series, we'll be taking this discussion ahead with Meterpreter. So let's quickly jump to a slide and understand what exactly Meterpreter means. Meterpreter is basically a command line based post-exploitation tool provided by Metasploit. In the previous videos, we merely focused on pre-exploitation processes, but from now on we will start working on post or exploitation processes where we will try to find further information about our target. Meterpreter is a built-in tool provided by Metasploit, which is a very powerful post-exploitation tool. Meterpreter works by in-memory DLL injection and native shared objects. DLL injection is basically a process where source code is run from within an already running process inside the memory. For example, explore.exe is a running process when the Windows operating system is running. So Meterpreter works by injecting its DLL inside that particular running process. So, what advantages does Meterpreter have for normal or traditional payloads? Individual payloads can do specific tasks. For example, they bind the TCP payload. These payloads can only do a specific task at a time, whereas Meterpreter can handle multiple tasks and can perform a variety of activities in order to help us have a deeper understanding of our target machine. Furthermore, Meterpreter does not create a new process in the target system memory. This means that whenever DLL injection happens, a new process is not created inside the memory. The major advantage of this is that the antivirus product will not be able to detect the DLL injection process. They will only be able to detect payloads if a new process is created. And finally, the last advantage of Meterpreter is that communication between the attacker and the victim machine is encrypted. It basically carries over the TLS or TLV protocol. Here is a simple block diagram of the working process of Meterpreter. Look at the first line of connectivity. The exploit along with the first stage of payload is sent onto the target machine. If the exploit process is successful, the payload tries to connect back to the attacking MSF console. Once it has a connection established, a third stage occurs. The DLL injection payload is sent again to our target machine. Now this DLL injection can load the Meterpreter source code inside the target machine. It can pick up any process inside the target machine and can inject the DLL into it. Hence, a two-way communication will be established between the attacker and the target machine. This is how the overall functionality of the Meterpreter is based. The reason why we are focusing on Meterpreter is that this is a very powerful post-exploitation tool that Metasploit provides. Hence, good understanding and command of Meterpreter can help us in better understanding and deeply navigating our target machine. Now that we've built up enough technical information about Meterpreter, we can implement it practically to further understand its different functionalities. If you remember, in our previous pre-exploitation videos in section 4, we mainly focus on exploiting our target machines using different client-side exploits and successfully received Meterpreter sessions. Once we have an active Meterpreter session, there are lots of things that we can do on our target machine. Let us begin with a Meterpreter prompt. Here I've used a Net API vulnerability in order to compromise a Windows SP Service Pack 2 machine and gain a Meterpreter session on it. First thing we can do is view the list of available commands by simply typing $? And pressing enter. Here we'll find a huge list of different commands which we can apply onto a live Meterpreter session. Let's begin with some basic commands. Firstly, let's try getUID. This command returns the username that is running on our target system. The other command that we can try is getPID. This command returns the ID of the process to which our Meterpreter has been currently injected. In order to view the complete list of processes that are currently running on our target machine, we can simply type PS and press enter. This will list all the processes that are currently running on our target machine. If you look at the process number 1392, you will see a svchost.exe process. That means that currently our Meterpreter DLL has been injected inside the SVC host process, which is a system process on our target machine. We can further understand about our target machine by typing svsinfo and pressing enter. This command will give us a basic idea about our target user, such as the computer, the operating system, into which we have broken in, and the architecture, whether it's a 64 or 32-bit operating system. We can further go ahead and launch a shell prompt, as well as using our Meterpreter session. We can simply type shell and press enter. This command will actually inject a small shell prompt similar to the DOS mode present in the Windows operating system. However, this shell actually sets up a remote connectivity between the attacking PC with the command prompt of our target machine. We can further exit the shell prompt by simply typing exit and pressing enter. So this was a basic demonstration of passing different commands onto the Meterpreter session and executing it on our target machine. We can browse the complete list of commands by typing question mark, viewing all the commands available inside the Meterpreter. There are lots of interesting commands that we can try once we've gained a live Meterpreter session. In this video, we'll discuss about privileged escalation. Privilege escalation is one of the very important aspects of penetration testing. Now, while trying to penetrate our target, we might break into the system of a user who may or may not be the administrator of that particular system. If the user is not the administrator of the system, will not have the same access rights as in the case of an admin system. So, in order to escalate our privilege so as to have the same access rights as the administrator, we follow the process of privilege escalation. Meterpreter provides us a unique command in order to help us escalate our privilege on our target machine. This system command gives us the ability to escalate our privilege on the target machine. If you view the H file of getSystem, you will see the different techniques that Meterpreter implements in order to escalate our privilege. Let us quickly understand these techniques in brief. The first technique used by Meterpreter is named pipe impersonation. A name pipe is a mechanism that enables inter-process communication for applications that occur locally or remotely. So, there can be a scene where a remote process with high security levels can behave as a local process with comparatively low security levels. Once this behavior happens, the remote process can actually have a higher privilege of access levels on the system, which equals to any local process. The second type of escalation process is token duplication. Every user on the operating system is provided with a unique token ID. This ID is used to check the permission levels of various users of the system. Now, if a user with a lower privilege is able to duplicate the token of a user of higher privilege, that lower privilege user can behave as a system administrator. The third type of privilege escalation process is KitTrap OD, or the KitTrap OD exploit that exists in almost all versions of Windows. This is a BIOS exploit which is triggered when a 16-bit application is opened on a 32-bit or 64-bit Windows architecture. So, this was a brief idea of different privilege escalation techniques that Meterpreter implements. Now, in order to execute this, we can simply type getSystem and press enter. So we got the output as GotSystem via Technique 1. Technique 1 is a name pipe impersonation. So Meterpreter tries all techniques that are available until we escalate our privilege equally to that of the administrator. Using getUID will now reflect that you are the administrator of the system. So this was a quick demonstration of how we can escalate our privilege on our target machine. In this video, cover some of the Meterpreter file system commands. File system commands provide us the power to explore different files, download different files, or view different files that are available on our target machine. We can also use the file system commands to upload our own files onto our target machine. Let us start with some of the basic commands. The pwd command reflects the present working directory in which we are currently communicating with our target machine. We can also change the directory by typing cd, that is, the change directory command. So, if you look at the present working directory, it has changed to C prompt now. You can also search for a particular file by using the search command. Let us quickly view the H file to see what parameters are required for the search command. So we require the type of file we want to search and the directory where we want to search. Let us give the file type as docfile and let's search the C directory for it. So, the following search files that you can see here have been searched by Meterpreter. If you look at the first one, secret.doc, it can be of some interest to us. We can download this file by using the download command followed by the location for where we want to download it. We also have to provide the location where we want to save the file in our own system. Okay, so the file has been successfully downloaded into our root folder. We can also upload a file from our machine onto the target user by using the upload command. Suppose I want to upload virus.exe command in the C directory of our user. I'll do so by using Meterpreter upload root virus.exe c. As you can see, the file has been successfully uploaded. Let's now move to our target machine and see if the file is available there or not. As you can see, the file has been successfully uploaded to our target machine. This was a short demonstration of how we can use different file system commands available to us in Metasploit. In this video, we will learn about some user interface commands associated with Meterpreter. We will mainly be focusing on getDesktop and keystroke sniffing commands. Before we move ahead, we should discuss the architecture of the Windows desktop environment in brief. This can help us understand the keystroke sniffing process better. Here is a technical block diagram of the Windows desktop. Now, the Windows desktop is divided into multiple sessions, out of which the session 0 represents the console. The other sessions represent remote desktops. These sessions are further divided into stations, out of which WinStation 0 is the only interactive Windows station. These stations are further divided into different desktop environments, which we see in front of us while working on Windows. The first one is the default desktop environment, which is the original GUI we work on while using applications and other programs on Windows operating system. The second one is the disconnect desktop, which is a screensaver of the Windows desktop environment. The third and last is the Win Logon desktop, which is the login screen that we see once we boot our Windows machine. Each of these desktop environments have their own keystroke buffers, which means that if we want to capture the keystrokes in the default desktop environment, we have to make sure that our Meterpreter session is listening on the default desktop. If we want to sniff on the logon passwords of the Windows machine, we have to make sure that the Meterpreter listens on the Win Logon desktop. Let's now move to our Meterpreter session and implement these commands. The first command that we can try is an enum-desktops command. This command lists the different desktop options available to us. The getDesktop command reflects the current working desktops on which Meterpreter is listening. Here you can see that Meterpreter is listening at the default desktop environment, which means that we can sniff any keystroke that is pressed inside the Windows environment. Alternatively, we can also change the processes in order to change our desktop. For example, listing the available processes by using the ps command. Here you can see that the Win Logon process is running with the ID 768. So, migrating to process number 768 by using Meterpreter will change our desktop environment to Win Logon. Now that we've migrated successfully, we can use getDesktop to verify that we have migrated. Now you can see that we've migrated to the Win Logon desktop environment, previously inside the default environment. Now we can pick up any default process, such as the Explorer.exe, which is the default Windows process to go back to the default desktop environment. Now as you can see, our desktop environment is again set to default. In order to begin the keystroke capturing, we use keyscan_start. So now our keystroke sniffer has started. Let's now go to our target machine and do some operations. Let us move to gmail.com, enter a user ID, a password, and sign in. Now let's come back to our Meterpreter session and do a keyscan dump. This will dump all the keyscans it has recorded so far. So here you can see that the user went to gmail.com and entered a user ID and password. So this is how we can sniff different passwords. Now, if we want to sniff the Win Logon password, we can either change our desktop environment using the setDesktop command, or we can change our process to Win Logon by using the migrate command. This is how keystroke sniffing actually works. So, this was a quick demonstration of how getDesktop works in conjunction with the keystroke sniffing command. Another interesting command that is provided by the Meterpreter is the screenshot capture command. This command actually takes a screenshot of our target desktop. You can see that a screenshot has been taken and saved in our MSF3 directory. We can easily go and view the screenshot to have an idea of what exactly our target user is doing. These are some of the important commands that are available to us in the user interface of Meterpreter. Let's now begin with the 6th section of our video series. In the previous video, we learnt about the basic implementation of Meterpreter. In this section, we will take our discussion a step ahead and we will try and learn some advanced implementations of Meterpreter. So, we'll be starting with passing the hash in order to bypass the Windows login screen. Passing the hash is the process of extracting the Windows logon hash bytes. The hash dump Meterpreter script extracts and dumps the password hashes from the target machine. Hashes can be used to crack the logon passwords and gain authorized entry to enter other systems on the LAN for future penetration testing. Hashes are a security mechanism that is implemented by Windows in order to store the login passwords. They're generally stored inside the System32 directory. The files are locked by default and even the administrator cannot access it through his account. So, if we are implementing pass the hash attack, we have to make sure that we are working as the NT system authority. In the previous video, we used the system command to escalate our privilege. So let's first implement the get system command. Now, if you do get UID, it will reflect that our privilege has now been escalated to the admin level. So now, for dumping the hashes of our target machine, we'll be using the hash dump command. The hash dump command has dumped the hash files for the administrator account, user account, and the guest account. Now, in order to crack these hashes, two processes are followed. One is a normal brute force attack that can be implemented by using brute force password breaking tools, such as Don the Riper. The second method can be using rainbow tables, which are also available online on some websites. Here, we'll be taking an example of a very popular MD5 cracking website. That is md5decryptor.co.uk. Here we have the option for NTML decryptor, which will decrypt our NTML hash for a readable form. Let us copy the hash value for guest user and paste it into the MD5 decryptor to see if it successfully decodes it. Here, you can see that the NTML hash file has been successfully decoded, and the password to this corresponding hash file is 123. Let us now try the same mechanism for the administrator account. Here, you can see that the administrator account does not have any password. In fact, this NTML hash corresponds to an empty string. Here, you can see how easily we decoded the passwords from the hash dump. But, in cases where the passwords are too complicated, using normal online-based rainbow tables may not be as helpful. In such cases, we can implement software-based, brute-forcing attack methods. In this video, we will discuss setting up a persistence connection using Meterpreter. The attacking PC, or the target PC, may not be available every time while we are pen testing. We may compromise the target machine at one instance, but at the other instance the target PC might be down or turned off. So, how do we ensure that we have a back connection at our end whenever the PC goes live? This is done via setting a persistence connection, or setting up backdoors in our target machine. Here we'll be discussing two important Meterpreter scripts. One is the Met-SVC script, and the other one is the persistence script. Let us start with the Met-SVC script. So, the Met-SVC script creates a temporary installation on the target machine. This installation contains a reverse handler similar to the one that we activate on our attacking machine. This reverse handler starts running on the target machine, and then whenever that machine is up, it connects back to our attacking PC. In order to execute the Met-SVC script, you just have to pass the capital A parameter. There you can see that several files have been created inside the temp directory. A reverse handler has been created and a session has been opened. Every time the PC will boot up, these temp files will automatically get executed through the registry entry and connect back to our target machine. Let us close this and move our discussion to the second script, that is the persistence script. This script has more options compared to Met-SVC. So here you can see the persistence script has several values like the A parameter that automatically starts a reverse handler. We have the S parameter that automatically starts the agent when the system boots. We have the U parameter that starts the reverse agent every time the user logs into the system. And we also have an interval. Once we set this value, every time the backdoor will try to establish a connection back with the attacking PC. So let's move on and execute this script. I'm going to give an interval of 60 seconds, define the port number as 4321, and use the R parameter to give the IP address of the system running Metasploit. Here, we see that once we command these, they execute successfully. We'll see that several temp files will be created. There's also a payload file that is created. The payload has been dropped and its parameter values have also been passed. A temp file has been created inside the target machine as well. Furthermore, a reverse connection has also been started. The auto registry entry has also been built on the target system. This registry entry will enable this backdoor every time the PC boots. And finally, we have a Meterpreter session active with us. This is how we create a backdoor on our target PC to have a system connection. The only drawback with this script is creating files inside the temp directory. It may trigger flags inside antivirus products. So, we have to make sure that we use the kill AV script, or we should kill the antivirus processes before we run this script. In this video, we'll take a quick look at Meterpreter networking commands. Covering these commands will enable us to understand the forthcoming videos, which we'll be discussing in this section. To start with Meterpreter networking commands, we have three basic commands that can be helpful for us. The first one will be the ipconfig command. Here I'm starting with my Meterpreter session. The ipconfig command basically represents the complete configuration of multiple IP addresses that are provided to our target system. Here you can see that one of the interfaces has a local IP, another interface has a LAN IP setup. Then there is another LAN adapter setup that has an IP in the range of 10, 0, 3, 15. And finally we have one more Ethernet adapter that reflects the same IP address. So, the ipconfig command basically represents the different adapters and a particular address used in order to access these. Moving ahead to our next command, we will be discussing root. This command has been of interest to us and basically reflects the routing table that is currently saved inside the default interface of our target. Routing tables basically give us an idea of different routing mechanisms that the TCP packets are following inside the target machine. This root command is very much similar to the root command present in our MS-DOS mode. It basically displays what can be used to modify the local IP routing table on the target machine. Now in order to understand how we can add our own routing procedure here, we use the H parameter. Here you can see that we have add, delete and list options available to us. The format in which we can provide the routing information varies. For example, to add we will have to provide the root. The first one asks for a subnet. Then it asks for a net mask. And finally it asks for a gateway. Here you can see that it's created the route according to the values that we have passed. The third interesting command that Meterpreter provides is the port forward command. Let us first see what port forward actually means. Look at this presentation. Suppose our target PC is an SSH server, and we, being the attacking PC, have gained access to this SHH server. Now, there can be a scenario where there is another IRC server that we cannot access directly. But the SSH server, which is our target server, or the server that we have compromised, has the access to the IRC server. So, we can build up a tunnel. If you look at the purple line in the second half of the diagram, you can see that this tunnel can actually forward every data from our attacking machine to our target machine, and finally to the IRC server. This concept is known as port forwarding. We are using our compromised machine in order to access the IRC server. Meterpreter provides us with the port forward command, which is port FWD. When we look at the help file, we can see the port forward has different parameters, such as capital L, which is the local host we want to listen on, L, the local port we want to listen on, P, the remote port to connect to, and R, the remote host we want to connect to. So a simple port forward command will look like this. The capital L parameter will add the local host on which we're going to listen. If we just give the local IP, we can give the port number, for example the local port, as 5678. The remote host we want to connect to is any remote IP like 165.56.45.7. And finally the remote port on which we want to connect to. Suppose that our IRC server was on port 667. So this is how a typical port forwarding command looks like. So this was a quick demonstration of different networking commands and how port forwarding actually works and is implemented inside the Metasploit framework. So far, we have covered most of the major Meterpreter commands. You must have noticed how powerful Meterpreter can be during the post-exploitation phase. In this video, we'll be covering another interesting Meterpreter concept which is called pivoting. Let us first understand what exactly pivoting means. Pivoting refers to the method used by penetration testers that uses a compromised system to attack other systems on the same network. This is a multi-layered attack in which we can access even those areas of network which are only available for local or internal use. If you consider the scenario shown here in this diagram, the attacker can compromise the outside nodes that are connected to the internet. These nodes are then connected to the firewall. Behind this firewall there is the main server. The attacker does not have a direct access to the server, hence he can use these compromised systems in order to access the internal server because those compromised systems are directly connected to this particular internal server. This is a typical scenario of pivoting. Now, the first question that arises here is what is the difference between pivoting and port forwarding? If you remember, in port forwarding we said that we can only access the internal servers using the compromised system. But if we also have to attack those systems, we'll be using the concept of pivoting. This is the only major difference between the two concepts. To implement pivoting, let's go to our Meterpreter session. Here we have an active Meterpreter session with our target machine. Let us run an IP config to figure out what are the different networks to which the standard machine is connected. Here, you can see that it's connected to a LAN having the IP range of 192.168.56.102. Furthermore, it's also connected to another local area network with the IP range of 10.03.15. This IP address looks interesting to us. What we can do here is that we can do a quick ARP scan on this IP range to figure out what other machines are live on this network address or network range. In order to run an ARP scan, we'll be using a Metasploit module called ARP Scanner. We've now done a complete ARP scan. You can see that the scanner's figured out some live hosts in this network range. The IPs are 2, 3, 4 and 15. After the scan is complete, we have figured out some live hosts. These IP addresses are not directly accessible to us. But since we have the hold of our target machine, we can use the concept of pivoting in order to attack these machines as well. In order to make an indirect communication with these machines, we'll have to modify the routing table of our target machine. We discussed about the root command in our previous video. Let us implement it here once again. Now let's push our Meterpreter session to the background zone. Now, let us add information and let us try and connect to 10.0.3.2 machine. So, the route has been added and an indirect communication is established. Now, you can run quick Nmap scans, or try to figure out what types of operating system is running on the machine. Or, we can see if we can launch any client-side exploits or not. We've already discussed these techniques in our previous sections. So this was a quick demonstration implementing pivoting using Meterpreter. In this video, we'll finally conclude our discussion about Meterpreter. You have noticed that the Meterpreter is a very powerful post-exploitation tool, which really eases up our task in many ways. In this last video of Meterpreter, we'll discuss another very important concept, which is called Railgun. Railgun is an interactive Ruby session that can be started any time on our target machine, irrespective of whether the target machine has Ruby installed on it or not. The question that arises now is why do we need a Ruby session on our target machine? Well, there can be scenarios where we want to run a Ruby script that is not part of our Metasploit module. In those cases, Railgun becomes a very handy tool. The Railgun session can be launched by simply typing IRB and pressing enter. So here you can see that our Ruby interpreter is now started. This is a fully functional Ruby interpreter where we can pass on normal scripts to it. Let us do a simple print script. So it's resulted in an output which is the result of the string. This we want to print. We can also do simple mathematical operations on our Ruby interpreter. Now the interesting part is that we can call any Microsoft DLL on our target machine using IRP. There are various types of DLL files which we may require during our penetration testing process. Metasploit has limited access to DLL files, If, suppose, in any case we want to execute a DLL file which is not present in any of the modules, we cannot close our session and go back to write a complete script to the particular DLL. We can simply go to the MSDN library and figure out which DLL we want to load, and then use our IRB session in order to load that DLL on our target machine. For example, consider that we want to load a DLL which checks whether the user is admin or not. As you can see, it's returned the value as true. This means we are working as administrator of the system. In this way, we can call multiple DLL files onto our target machine. Let's now go back to our backtrack session. A complete Railgun manual can be found in the directory inside our Metasploit installation and can be done by using OPT, Framework 3, MSF3, External, Source, Meterpreter, Extensions, STDAPI, Server, and then Railgun. This folder contains the PDF file Railgun Manual PDF, which can be a very helpful guide in further investigating this interesting tool. This was a final, concluding video about Meterpreter and post-exploitation. In the next session, we'll be discussing about interesting auxiliary modules which are present in the Metasploit repository. Let us begin with the 7th section of our video series. So far, we have covered multiple stages of penetration testing, starting with information gathering, remote exploits, and further the post-exploitation process. Meterpreter was a very important concept, which we'll learn quite in detail in our previous 2 sections. Moving ahead, the next important part of Metasploit is the auxiliary modules. There are different types of auxiliary modules available to us inside Metasploit. Let us now take a look at the modular directory structure. Inside the modules directory, you can find the auxiliary folder which contains all the relevant auxiliary modules present in Metasploit. If you go inside this directory, you will find several subdirectories, classified as per their type. You can see the admin auxiliary module, crawlers, DOS-based attacks, fuzzers, SQL injection, sniffers, scanners, and so on. So as you can see, there are several auxiliary modules available to us. We've seen the use of auxiliary modules in some of our videos. Let's now cover them in detail. We'll start with the scanner auxiliary module. Here we can see that we have a huge range of scanner auxiliary modules available to us. These modules are generally defined to perform specific tasks. Scanner auxiliary modules come into action when we want to scan a particular type of service or an application, for example, the MySQL modules. Here you can see that we have some MySQL-based scanner auxiliary modules that are designed for specific purposes. Let's now move to our backtrack prompt and use some of them. Now let's choose the MySQL login module. Now let's run show options. So here you can see that this module picks up a lot of information. The module is actually designed to first figure out whether our target is running MySQL or not. Based on the fingerprinting process, it further moves ahead to apply the brute force password guessing technique. Here you can see that we can pass on different files like the user pass file. This file can contain different passwords. Similarly, try the username, our hosts, specific passwords that we want to try, and so on. There's an interesting file with an interesting parameter called userpass_file, which can be a file containing users and passwords separated by space. So, just like we worked on exploit modules, we can set the parameter values here also. Let's suppose we give a text file name as userpass.txt, which contains usernames and passwords. Pressing enter will pass the parameter value. Let's also pass the rhost, which is a required value. Here, you can see that the rhost is a plural word. It means we can provide multiple IPs or a range of IPs. Using the run command, we can quickly execute this auxiliary module and analyze its results. So this was a quick demonstration of how we can use scanner auxiliary modules. Similarly, we can try out all the other auxiliary modules that are present. You can see that there are multiple fingerprinting modules available, such as the HTTP modules, MSSGL database modules, port scan modules, and so on. Moving ahead with our module experimentation. In this video, we will learn about some admin modules that can be really handy during the penetration testing process. The admin modules can serve different purposes, such as it can look for different admin panels. For example, if it's a MySQL database auxiliary module, then the admin module lets you look for an admin panel, if it is possible through a directory traversal. The admin modules can serve different purposes, such as looking for admin panels or trying for admin logon. It depends on the functionality of the module that we are targeting. Here, we will start with a simple admin auxiliary module. Let us first browse to the admin auxiliary module directory. Here we can see that we have multiple options for different types of tools, protocols, application software, and so on. We also have database software such as MS SQL, Oracle, and MySQL, along with the FTP-based and specific appliance-based ones such as Cisco and EMC. Let us try one of these modules here in our Metasploit prompt. Now let's try the enum module and do show options. Okay, so it requires rhost. So, here you can see that the basic operation of auxiliary modules is very much similar to the exploit modules that we saw in the previous two video series. The only thing which differs is the auxiliary modules are meant for a specific purpose. For example, this MySQL enum module will particularly be looking for enumeration of MySQL databases. The run command will quickly run this exploit for you. Let us check what we have inside the MySQL data source code. Here, if you take a close look at the module source code, it is a simple Ruby program that looks for the enumeration of MySQL database server. Also, you can provide credentials if you are aware of it. Looking at this code here, you can see that the module follows a definite structure. First, all the values are initialized, and the other important parts of the module is the run, where after successful enumeration, different parameter values are passed. Similarly, we have other important modules, such as the Tomcat administration module, that looks for the presence of Tomcat with the default directory traversal in it. This module is present inside the HTTP directory. We can see the admin folder, and inside it, the HTTP folder. Here we can find the Tomcat administration or different auxiliary modules pertaining to Tomcat. Just like we saw in the example of the MySQL enum module, we can similarly use the Tomcat module as well. We can do a quick show options and pass an rhost, and then run the auxiliary module in order to get the result. This was a very simple demonstration of how we can use the admin auxiliary modules for penetration testing. In this video, we'll be covering DOS auxiliary modules. DOS, or denial of service, is an attempt to make a machine or service unavailable to intended users. Consider, for example, a web server. If an attacker sends huge amounts of malicious requests to the web server, the services or the capacity of this server will be consumed, and a legitimate user will not be able to access the content of the server. This is a very basic scenario of denial of service where a legitimate request is dropped down due to the overloading of service. This leads to the denial of service attacks. Penetration testers use denial of service as a stress testing procedure for different applications or services. Metasploit contains several auxiliary DOS modules which can be helpful during these cases. Here, inside the DOS directory, we can find several subdirectories classified according to the products or services. For example, we have Cisco-based DOS modules, protocol-based modules like HTTP, SSN, and SMTP, and we also have particular DOS modules for Windows operating systems. So you can see that we have multiple operations performing DOS over a wide range of services applications. Let us quickly implement a simple HTTP Apache-based module in which random generated requests will be sent to an Apache server. Here we can look at the source code of the module. It's basically a kind of vulnerability having CVE 20113192 that exists in Apache server. The implementation is very much similar to what we've seen so far. We'll be implementing the range DOS and the show the options by using MSF, use auxiliary, DOS, HTTP, Apache range, DOS, and then use show options. Alright, so we have the rhost set up, and rlimit is basically the number of requests to send onto this target. So, let's increase it to 50,000 and press enter. Before we run the auxiliary module, let us go to our Windows machine. Here is a task manager that shows the network activity. You can see that there is absolutely no activity so far. Let's go back to our Metasploit prompt and run the module. So, here you'll notice that suddenly a network activity can be seen in our target PC. This is because our auxiliary DOS module is sending random requests onto the HTTP server that is present on our target machine. We have given the limit as 50,000. Now, if a stress limit is reached, a crash or a denial of service will occur at the target's end. This was a simple demonstration of DOS modules. Similarly, we could try out all the different modules which are present in Metasploit. In this video, we'll be covering fuzzer auxiliary modules. Fuzzing is basically treated as a black box testing technique where we test for the maximum overflow capacity of any software or application. Fuzzing is very actively used to find bugs in the application. Fuzzers can be used to test software protocols or different file formats. Fuzzers follow a definite pattern. They create a combination of random numbers or characters or metadata and pass it into any input parameter that the software or application accepts. Fuzzing helps us in testing the stress limit as well as the boundary limit of any application or protocol. Metasploit has a good number of fuzzing modules that can be very helpful for penetration testers. This can help in examining any application or protocol for its various stress limits. Here, inside the auxiliary directory, you can find the fuzzer modules. Inside it, you can see multiple subdirectories that are categorized based on the type of application or protocol. You can see that we have DNS, FTP, HTTP-based fuzzers, SMB, SMTP, and so on. Looking at the HTTP fuzzers, you can see that we have 3 different fuzzing modules available to us. Let us quickly view the getURI fuzzer module. If you look at the code, it says that this module sends a series of GET requests with incrementing URL lengths. So this fuzzing module basically tests the target's HTTP server by sending multiple GET requests and continuously incrementing the URL length. There can be a boundary condition at which the HTTP server at the client's end may crash, or may allow remote code execution. So let's quickly move ahead and implement this fuzzing module in our Metasploit session. We'll be using getURI long. Here you can see that it is asking for the R host. Also, it's the longest string length to try, which is by default set as 16384, and can very easily be changed to whatever value we want. Passing on the run command will execute the module, and the fuzzer will start sending different GET requests for URI lengths of varying sizes. Here you can see that the length is continuously increasing. First we had 100 bytes, then 200, then 300, and so on. So this is how the HTTP server installed at the target site will be tested through the fuzzing module. Similar operations can be performed on the other fuzzing modules which are presented to us in Metasploit. We're now starting with the last video of the 7th section. In this video, we'll be covering the post-exploitation auxiliary modules. So far, in the previous 4 videos, we've basically covered those auxiliary modules that were either related to the pre-exploitation or the exploitation phase. Now with this video, we'll be covering the post-exploitation modules. As you can figure out, to execute the post-exploitation modules, we'll be requiring an active shell or Meterpreter session with our target machine. Also, the directory location is slightly different from what we've seen in the previous 4 videos. Previously, we were looking under the auxiliary directory to figure out our different modules. Now, for the post auxiliary modules, we'll be looking at the post directory inside the modules folder. This directory basically contains different modules that can be used in the post-exploitation phase. Here you can see that we have different subdirectories that are classified based on the operating system or the appliances. If you go into the Windows directory, you will see that there are again subcategorized modules based on the type of activity they perform. If you look at the capture directory, you'll find that there are 2 modules. One is the keylog recorder, and the other is lockout keylogger. So, as you can figure out, these 2 modules are useful in case we want to recall the keystrokes pressed on the target machine. Further, we have the escalate folder. In here, you can see a very well-known module, which is the get system. If you remember, we used get system in our videos while we were discussing Meterpreter. This module will help us in gaining administrator level privilege onto our target machine. So here you can see that there are many modules that we've already discussed in our post-exploitation phase while we're working on Meterpreter. Similarly, we have the gather folder and the ARP scanner, which we use while we're working on pivoting and port forwarding. There are many different modules which we can use and implement in post-exploitation phases. Metasploit has a very rich repository of post-exploitation modules, which can be very helpful, and they can be very easily modified at any time by simply viewing the source code and analyzing them. So this was a quick demonstration of the directory structure of post-exploitation modules that are presented to us in Metasploit. Let us begin with the 8th and final section of this video series. So far in this video series, we have mainly focused on Metasploit and its console. In this final section, we will be focusing on Armitage. Armitage is basically an extension of Metasploit. Armitage adds the GUI version or the graphical interface into the Metasploit framework. The core process of Armitage is based on setting up a graphical interface and generating Metasploit queries based on the inputs provided by the user. So let's move ahead and see how we can leverage the power of Metasploit and its graphical interface to ease up our task of penetration testing. The overall structure of work remains similar to what we've seen so far in Metasploit. The only added benefit that we get here is that we have a graphical interface in front of us. So we can maximize our effort by quickly performing different tasks. To start with Armitage, we have to make sure that Metasploit is running properly. Also, we need to make sure that the database used by Metasploit is up and running fine. Let's check the database status by using msf db status. So it seems that PostgreSQL is connected to MSF3. In case it is not connected, you can easily use the command to start PostgreSQL. If you pass this command into the init.d framework postgre start, you will see that it says the server is already running. To start Armitage, you can go to Applications, Backtrack, Exploitation Tools, Network Exploitation Tools, Metasploit Framework, and Armitage. You will see a simple connecting window with credentials like the host IP, port number, username, encrypted pass, database driver, and a string to connect. Make sure you click on Start MSF in order to begin working with Armitage. Once you click on it, you will see an RPC Java exception being thrown. This is just a simple warning. Once it completes, you will see that the Armitage window loads in front of you. So this is how we can load the Armitage interface. In the next video, we will further explore the different dimensions of Armitage. Moving on from our previous video, we have successfully launched our Armitage GUI interface. Now if you look at this interface, you can find several known phases. Let's now quickly have a look at them. Here, to the extreme top left, you will find a search panel for where you can search different modules related to Metasploit. You can find the auxiliary modules, exploits, payloads, post modules, and so on. The next window pane is basically the graphical representation of different targets available to us. Currently it is blank since we have not yet launched any type of attack or any type of scan. Further down, the third part of this GUI represents the Metasploit console. It is the same console on which we have worked so far throughout our video series. Whatever activity happens on this GUI can easily be interpreted inside the console window as well. You can also disable it by clicking on the cross button. Further, looking at the different options, if you look at the first tab, Armitage Preferences, this represents the default preferences which are set up inside Armitage. You can easily change the preferences, such as setting up the console, or setting up the graph selection, or view properties, and setting up shortcuts. You can change these values by simply double-clicking on them. The next tab you can see is View, where you can set up different view formats for consoles, credentials, jobs, or targets available. The Host tab is important. Here we can import different file formats, Nessus scan results, Nmap scan results, and so on. We also have scan options and can add our own host among other things. The Attacks option further lists different types of attacks or different types of attack vectors that we can implement using Armitage. The Workspace tab is basically a way in which we can create a workforce or a project for our penetration testing. Simply name it anything like Pact and click OK. This will create a different workspace for us. Further, the last tab is Help, from where we can get different tutorials or we can go to the home page of Armitage. So this is an overall format of how the graphical interface of Armitage is designed and how it correlates with Metasploit. We will continue our video series with Nmap, just like we did when we started the scanning process while working with Metasploit. We will now move ahead to our third video of this section. In this video, we will start our penetration testing process using Armitage. Now that we have understood the overall GUI structure and implementation of Armitage, we can now move ahead and launch our different penetration testing processes. To start with the most basic step, we'll be starting with a simple Nmap scan in order to figure out the live services or live host on any network. To launch an Nmap scan, we can go to Hosts and from there to Nmap Scan. Here you will see that different options are listed. Let us select the Quick Scan process. Here you can either give a single IP address or a complete network range in order to figure out which systems are live in it. Consider for example 192.168.56.1-24. This can scan the entire network to figure out live hosts. Let us then click OK. You will notice that a db_nmap command has been sent to MSF console. Let us wait until the complete scanning process is finished. After some time, you will notice that the Nmap scan finally finishes. It takes a little longer to finish here. Once the scan is complete, you'll notice that the attack window portion of the GUI reflects the different targets based on the type of operating system they have. For example, looking at 192.168.56.1 machine, we can figure out that this machine is using a higher version of Windows, which is Windows Vista. Further, the next machine is using a Windows XP. We also have a Linux-based system available here. So you can see how precisely and nicely Armitage reflects the different live hosts after the Nmap scan. Now the other interesting feature is finding out different services. If you right-click on any host, you'll find a tab called Services. If you click on it, you'll notice that a new tab opens which reflects the different services along with the port numbers for the particular target. Similarly, we can select another target, right-click on it, and view the available services. Once you click the services, you'll notice again that a new tab has opened. So, in this way, we can manage multiple targets by simply switching between the tabs. We can immediately switch to the Nmap console, or we can switch to the Services tab, and so on. This is how the mobility is increased while we're working with the GUI environment of Armitage. This was a quick demonstration of how port scanning is performed using Armitage. In the next video, we'll move ahead to launch our multiple attacks over the targets that we've selected using Nmap. Let us begin with the fourth video of Section 8. In this video, we will learn about launching attack modules using Armitage. In our previous video, we saw how we can scan an entire network range in order to find out live hosts. Our next target will be to explore the vulnerabilities that could be exploited on those machines. If you remember, when we run an Nmap scan, it also lists different open ports or the different services running on our targets. To see whether those vulnerabilities are exploitable or not, Armitage provides us a quick GUI option. Simply select the target machine, move to Attacks, and from there, find attacks. Here we have two options: find attacks by port or find attacks by vulnerability. You can select either of the two based on your preference. Let us select find attacks by port. Now Armitage will start scanning this machine to figure out which ports are open on this machine and based on the version of services available on those ports. It will conclude the types of attacks possible on them. Once Armitage has figured out its calculations, it will show a pop-up message that the attack analysis is complete. Now if you right-click on the target, you'll find a new tab option called Attack. Here you'll find different options listed which tells us about different exploit modules that can be implemented on this target. We'll come now to the SMB option. Here we'll find the same Net API vulnerability that we have used in our previous videos of Metasploit. Now, if you click on this module, you will find several options similar to those that we've seen while working on Metasploit. We can see that it is asked for an L host, L port, R host, R port, and so on. Now you can provide the respective values to launch the attack modules. Clicking on the Launch button will begin the exploitation process automatically, and after some time, Armitage will send us the report based on whether the attack was successful or not. Another interesting option that Armitage provides is SMB. Right-click on Target, move to Attack, and then SMB. The last option says Check Exploits. If you choose this option, Armitage will apply all the exploit modules one by one listed under the SMB category. Here you can see that the console that Armitage has started trying all the SMB exploit modules. If any of these attacks are successful, Armitage will return a back connection similar to what we have seen in Metasploit videos. These are the few automated options that Armitage provides us. These options not only ease our task of penetration testing, but also increase the productivity or work we do on our target network. Let us move to the last and final section of penetration testing using Armitage. In the previous video, we launched a remote exploit and successfully compromised our target using Armitage. Now once the target has been compromised, if we right-click on it, we will notice that a new tab option of Meterpreter has been added. This reflects the different processes that we can perform on our target machine. For example, the first one is access, which reflects the different access-related processes that we can implement on our target in order to perform multiple pen testing processes. As you can see, we have a duplicate option, migrate option through which we can migrate to different processes, privilege escalation, hash dump, persistence, setting up the backdoors, as well as the pass session. Let us launch escalate privilege in order to escalate our privilege to the system level. You can see that we immediately get a prompt saying that we now have system level access via technique 1. If you remember, we performed similar actions while we were working with post-exploitation using Meterpreter. Let's now check out more options. We also have an interact option where we can launch a command shell, a Meterpreter shell, or a VNC session. The explore part represents different pen testing processes through which we can explore our target in order to figure out its different file systems, storage files, and so on. We can browse the files, look for the processes running, do a key scan, have a screenshot, and a webcam shot. The webcam shot has been a bit buggy and it can lead to crashes, so this option is not recommended. Let us try out this screenshot command and see how Armitage represents it. You can see that a new tab has been opened, which reflects the present screenshot of our target. We can also refresh it in order to get a new screenshot. So you can see how nicely Armitage is setting up different processes and how it is segregating them into an informative and easy way. Further, we can check out more options, such that we can launch a key scan process. You can see that a new tab has been opened immediately. Here, Armitage launches a key scan process. Clicking on Start will begin our keystroke sniffer. So you can see, all these are the same pen testing processes that we've implemented while we're dealing with Meterpreter. Armitage eases up the process by simply providing us with a very interactive GUI by which we can directly pass on our commands to the Metasploit session and perform our pen testing process. Also, creating multiple tabs for different targets enables us to quickly interact with different targets at the same time. Furthermore, we can launch more exploit modules. For example, if we want to launch a particular file format exploit module, we can simply select any exploit and pass on its respective values in order to launch it against our target. So this was all in all an idea of how Armitage works, how we can perform scans, launch remote exploits, and later on, when an exploit is successful, how we can further penetrate our target using post-exploitation processes. You can further explore other possibilities by launching attacks, including those of the client side, as well as trying out different post-exploitation processes.